Unit 4, we are going to be studying polynomials. We're going to learn how to do a lot of things with polynomials, such as adding, subtracting, multiplying, and even dividing polynomials. But before we can do all of that, we really need to lay some basic ground rules, and that's going to be the polynomial vocabulary. Now, polynomial is just an expression made up of coefficients, variables, and constants. These words should be pretty familiar to you already. Remember that a variable is just a letter, so think x. And a coefficient is the number attached to a variable, so think like 3x. And a constant is just a number that retains a constant value. It does not have a variable attached, so think 3x plus 5. That is considered to be a polynomial. Now, there are two requirements for a polynomial. Number one, you have to have a positive exponent. And number two, even though fractions are allowed, the variable, the letter, cannot be in the denominator. So if you're working with an expression, those are the two things you need to check for to make sure that you're dealing with a polynomial. Number one, make sure that the exponent is positive. And number two, if there are fractions, make sure the variable is not at the bottom of the fraction. Let's look at a few examples. Which of the following expressions represent polynomials? Circle all that apply. How about the first one? 1/2 x cubed plus 5x squared minus 1. Are all of the exponents positive? Yes. And I see a fraction, but is the x at the bottom of the fraction? No. So this one's good to go. This one is a polynomial. How about the second one? 2m. It's kind of short to be a polynomial, but check the two requirements. Does it have a positive exponent? Yes, it's just a regular m. And I don't see any fraction at all, so this one's actually good. Even though it's a short expression, it still does represent a polynomial. How about number 3? P to the negative first power plus 11. Well, this one cannot be a polynomial because it has a negative 1 in the exponent. So this one's no good. You're not allowed to have those negative exponents. How about the fourth one? 4x squared y minus 5xy squared. Now here you're mixing in x's and y's, but check the two requirements. Are all of the exponents positive? Yes. And we don't have any fractions at all, so we don't have to worry about a variable being in the denominator. This one's good. Lastly, we have 4 divided by n cubed plus n squared plus 5n minus 7. Here, all of our exponents are positive, but the problem we see is we have a variable in the bottom of a fraction. That's no good. You're not allowed to have that. That last one is not a polynomial. Now that we've defined what a polynomial is, let's look at some more vocabulary. Here we have the expression 5x to the 4th power minus 9x cubed plus 7x squared plus 11x minus 13. This is a polynomial expression, and it's considered to be written in standard form because this is in order from the highest exponent all the way down to the lowest exponent. Now, speaking of exponents, the degree of a polynomial is just the value of the highest exponent. Here, our highest exponent is a 4, which makes this a 4th degree polynomial. That first term is also very important. That leading coefficient is the coefficient attached to the variable with the highest exponent. So in this case, our leading coefficient is a 5. Another important number in this sequence is the constant term. The constant term is the term that doesn't have a variable at all. So even though all the other ones have x to the 4th or x to the 3rd or x squared or x, the negative 13 doesn't have anything. That is called a constant. Finally, a word that I've used in these other definitions, the word term. A term is an expression that's separated by a plus or a minus. So see here we have 5x to the 4th power minus 9x to the 3rd power plus 7x squared plus 11x minus 13. Every time you have a separation by a plus or a minus, that's separating a term. So this one has 1, 2, 3, 4, 5 terms. Now, a few other definitions here. If you only had one term, so like 2m, that's considered a monomial because there's only one term. If you had two terms, something like 3x plus 5, that's considered a binomial because it has two terms. 3 terms, if you had like, I don't know, x squared plus 5x plus 4. If you have 3 terms, that's called a trinomial, and anything beyond that would be referred to as just a polynomial. Let's take a look at one more example. Here we have 6x plus 17 minus 3x to the 4th power plus 9x squared minus 7x cubed. The first thing we want to do is write this expression in standard form. Remember, standard form is where you put the highest exponent first. So first, I need to start with the x to the 4th power. So that is a minus 3x to the 4th power. So I'm going to write negative 3x to the 4th power. After the x to the 4th power, I'm going to do the x to the 3rd power. So that's going to be minus 7x cubed. After the x to the 3rd power, I'm going to do the x to the 2nd power. So that's plus 9x squared. After x squared, we're going to do the regular x. That's a positive 6x. I'm going to put plus 6x. And last, the constant. Positive 17, I put plus 17. Now, if you count it out, that was 1, 2, 3, 4, 5 terms. The degree of this polynomial, remember, degree is just the highest exponent. The highest exponent was a 4. The leading coefficient is not necessarily the number at the front of the original expression, but it is the number at the front when it's written in standard form. So negative 3 is our leading coefficient because that is the number attached to the value with the highest exponent. Last, the constant is the number that doesn't have a variable at all. That's the positive 17.